I'm Melissa.
And I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life, bonus episode.
The podcast helps you understand the chemistry of your everyday life, but this time we do even more for the same price of free. 2 episodes this week. For the same low price of $0, you and your loved ones can experience twice the chemistry in 1 week.
Okay.
With 3 easy payments of $9.65.
You have to do the questions this time.
Yeah, I know. So, are you ready to get into our questions?
I'm ready.
Okay, sweet.
As ready as I'll ever be.
The first question is from 2 people, sort of. It's from Esty and Jordan. And they asked, what is the compound in the picture you posted? And this was from a little bit ago, actually. The compound that you made.
Oh, and the photosynthesis pictures from today's episode.
Yes.
The artificial photosynthesis. Yes.
Yeah.
So I think I replied to Esty on Instagram, but I don't know how to get on our Facebook.
Yeah.
So sorry, Jordan, that it took me so long to reply to your comment. Mm-hmm. That is a compound that I made in the lab. It's some derivative of, it's called azabodipi for short. Sometimes people call it bodipi, azabodipi instead of azabodipi. Depends on your accent, preference, whatever.
That's a weird word already.
And it's basically just a dye. And it's a dye used in dye-sensitized solar cells. So it's that beautiful teal color. It will dye your clothes. And it can turn brown when exposed to light because it decomposes. It can degrade. And then when the liquid is all evaporated from it and it's not dissolved in any kind of solution, it's red and sparkly like glitter, and it is beautiful.
Interesting.
And it's one of those times where the chemistry itself is beautiful, but so is the compound that you made. Sometimes you can make really incredible stuff and they just kind of look like sludge. That one is beautiful. It's so fun to make. It's gorgeous. It's every step of the way is beautiful. Even the separation techniques are beautiful. So that is one of my favorite compounds to make. And that's why I put it on there as a BODP. It's a derivative of that.
I think that's cool.
That name probably only means anything to chemists, but you can Google it.
Yeah. It sounds like a different language.
It is. It's a universal language of chemistry.
Oh, I mean, it sounds like some Latin-y chemistry medical things sound like that they are.
Yeah.
This sounds more like it could be someone's name or something like that.
The aza is for a nitrogen that replaces something in there, and the Bo is for boron, and then dippy is dipyro. It's a dipyromethane. So the full name is azaboron dipyromethane with a substitution at certain places, but nobody thinks that's interesting. So.
That makes a lot more sense than I thought it would, though.
Yeah.
Okay. The next question comes from Sean N. And he asked, this is based on the snowflake episode from just a couple weeks ago. Does the snowflake form in the clouds and then fall? Does it form as it's falling? Does it continue to form once it hits the ground?
Okay, Sean, I'm not an expert in snowflakes, but I am sure it's forming while it's in the cloud and it's moving while in the cloud. So in a way, it's falling, quote unquote, even while it's in a cloud. Molecules are always moving around. So the answer to the first question, in the cloud, as it's physically coming to the ground, I would say both of those are yes. It is possible that it gets to a point where it's warmer than freezing and it starts to melt. I do not think it would continue to form once it hits the ground because it's not encountering water molecules in the same way anymore. It's just around a bunch of other solids. That is my educated guess.
Okay. Interesting. Okay, the next question, or actually here's a few in a row from Stephen H. His first one is, do all molecules have a crystalline form if given the right environment to grow? Or are there certain properties the molecule must have, like a prime or square number?
That is a great question. I'm not 100% sure on the answer, but I'll tell you, if there's a higher amount of symmetry, it is easier to form a crystal. And again, crystal formation is all about highly ordered substance, and that usually comes as a result of intermolecular forces. So repeating units make it much easier to form that highly ordered crystalline. So if something is very oddly shaped with very little symmetry or big and bulky and weird, it is hard to make that nice, highly ordered substance. So my instinctual answer is theoretically, maybe. In reality, there are many molecules that would be unreasonably difficult to form into crystals, is my instinct.
Man, that's crazy. Can you imagine like an oxygen crystal or something like that?
Actually, oxygen, I think... Oh, maybe it's magnetic. Liquid oxygen does crazy stuff.
Oh, yeah.
But I don't... I'm pulling that out of the deep caverns of my mind, so I don't have to dive into that.
Okay, his next question is a comment. Black holes also bend light and make it impossible for us to see what they actually, quote unquote, look like. Light bending is mind-blowing to me.
Steven, that's so interesting. I did not know that. That's so cool.
Wait, like impossible for us to know what they look like?
I didn't know any of that about black holes.
Ah.
I know very little about the cosmos. Something about that makes me...
That's my world. I mean, I don't know like a ton, but it's like I love it. So Steven and I are kind of are in the same game here.
Nice.
Sci-fi, black holes, all of that. As much as you can throw at me, I'll take. Even if it's kind of like just a story about it. That's why I keep bringing up 2001: A Space Odyssey all the time.
Oh, because it's in that vein. Yeah, that stuff. Real space interests me. Sci-fi does not.
So the best rendering that has been available of a black hole to the most people is what they did in the movie Interstellar. They decided to just go ahead and let like actual astronomers and physicists and whoever needs to be involved in that go crazy to try their best to show what it actually looked like. And that's in quotes because really what you're just seeing is what it looks like to have an effect around of the light around it.
Right.
But it looks crazy. So I don't know if you saw that movie, but that's as accurate of a rendering as we have so right now, as far as I know.
Well, I'm mind blown. That's cool.
For the public. Like that, sure, some guy in some computer lab has like a crazy other version, but we have Interstellar. The rest of us have Interstellar.
I did not know that.
The next one is a correction from Anthony C. And he wrote, it's Professor Hulk, not Dr. Hulk.
I'll tell you what. In my mind, professor and doctor are interchangeable, number one, in the academic world. And number two, maybe they shouldn't be, but they are. And number two, I did say that I'd never seen that movie.
and I'm not going to like actually fight him, but I don't remember them saying it in the movie. Like maybe he's referencing a comic where they do that, where Bruce and Hulk become one. But I don't remember them saying Professor Hulk or Dr. Hulk in the movie. I just remember it being like people after the movie came out referring to it, like a meme or whatever.
Oh, yeah.
You know? But I don't think they ever said, they didn't start calling him, Professor Hulk, can I have a word with you? Or whatever. Or like,
I trust his knowledge on that one.
But if he's like drawing from comic knowledge, I would have no idea. So
yeah, I don't know anything.
And his next thing actually is a question. Yes. I'm not sure what a bond is or how it works in conjunction with the radical stuff. Now there's a period at the end, but I get what I think it definitely is a question overall.
I was the one that labeled it a question. Technically, I guess it could just be a comment.
Yeah.
That one is a good question, and I'm glad he brought it up because a bond is essentially two atoms being held together, and it's usually two electrons. That's what we were talking about in conjunction with the radical stuff. So a covalent bond is a type of bond that's two electrons that are shared between two atoms. So I like to say it's almost like they're holding hands. Each atom generally wants 8 electrons. So if there are two that have 7, they'll come near each other and they'll each have access to both of those electrons. There are other types of bonds like ionic bonds where one whole electron is lost and the other one is gained. One's positive, one negative. It's all kind of a spectrum of how much of the electron density is one place or the other. Kind of messy and complicated. But a very basic definition is a bond is two shared electrons between two atoms. And when that bond is broken, they call it a homolytic cleavage. So if it's broken in the electrons split one to each side, that would be a radical because it's one electron on each side instead of the shared.
Okay.
One unpaired electron. That's the best I can do in a short bonus episode about a bond.
Yeah.
But that's a good question. I didn't realize I'd kind of skipped over that in the explanation on that episode.
The next question is from two people, Isabel and Michael. Could you two, oh, not two, sorry. I mean, they said this, but I guess what they really mean is Melissa. Could you two explain organic chemistry?
Well, that's not true. You explain it too. You're the translator.
That's true. Yeah. I can only do my part though after you do yours. It's like
so it's the two of us.
Okay, yeah. Okay, good point.
Isabel and Michael, I have some fun news for you. We have already explained organic chemistry to you.
Ah.
Now, organic chemistry is just the chemistry of carbon-based things. So that would be soap. How does soap work? That was an episode about organic chemistry. My organic chemistry students use that. Enantiomers, left and right-handed, that we talked about in the episode about artificial sweeteners. Cis and trans fats. We talk about cis and trans bonds in organic chemistry a lot. How do we turn sunlight into energy? That is all research that was done in an organic chemistry lab. So I hate to break it to you, but you already know organic chemistry. And this is why I'm sad that organic chemistry gets such a bad rap, because it's super interesting.
We've been sneaking it to you guys.
We've been sneaking it in.
Bits at a time. Just like how Andrew Dufresne dug out of his jail cell.
Deep cut. What was a reference to... Should we say it?
Yeah, that was a Shawshank Redemption reference.
Shawshank Redemption. I love that movie.
It's so good. So, but maybe their question was like, sort of not getting where organic chemistry, like what it is, where it ends and begins. So your first at the very beginning, you said about carbon-based things.
Oh yeah.
Maybe that's kind of getting at what their main question is. I don't know. Well, it's hard to know without doing follow-up. But
Isabel and Michael, if you'd like to reach out to us and clarify your question, ask maybe more specifics. Do you just want me to be your organic chemistry teacher? Because then I can do that if you come to UNT. Just let us know.
Okay, sweet. The next question's from Josh C. What do scientific journals and articles actually even mean? How are they legit sources?
That is a great question. I'm really glad that someone asked that because I've referred to trying to find legit sources quite a bit.
Yeah.
Scientific journals or articles are peer-reviewed journals. So someone will submit their research findings, and that is reviewed by other experts in the field. They're given reviews on them, and they may have to make revisions or changes, and then it is submitted. So when we find science in those articles, we know that it has been vetted through many eyes, and these are usually blind reviews, or they're not trying to help each other. It wouldn't be like, I reviewed my friend's paper.
Oh, got it.
In general, the goal is for a rigorous scientific process to check one another. That's a peer-reviewed journal or article. I look for those sources. When I'm checking my sources, I look for journal articles in the American Chemical Society journal, which is a very well-renowned one, or in other well-renowned journals, or I look directly in textbooks, which have been reviewed and edited and are trustworthy sources. So part of being in the field for a long time is being able to recognize those sources. And sometimes I'll use stuff like the Scientific American or other magazines that are known for good journal sources, and they cite the specific paper that it comes from, so I can go look at that.
Nice.
So, or I can figure out which paper it is based on the name of the person they're interviewing. So in general, I work very hard to have legitimate sources that I am confident have been reviewed by other scientists or that are coming from a textbook and reviewed from other scientists. But that's sort of the basics of how you can look for a quote legit source, but it is difficult. So I may Google to find something, but I'll sift through to look. I don't even look at the titles until I see American Chemical Society or something that seems trustworthy.
And then some things you've looked at too have been like sources that you have access to through the university or through your peers or the textbooks that you use or teach from or whatever.
Right.
So it's like those are probably equally rigorous process to make sure that they're legit.
Yes. And a lot of scientific journals or articles you have to be subscribed to.
Yeah.
And the university does that subscription. So I'm able to get all of those.
Mm-hmm.
So I'm really lucky in that.
Yeah. That's really helpful for me to hear too. I don't think I really thought about it, but it's like peer reviewed. It's not like I'm trying to give my buddy a good thumbs up on his article that he worked hard on. It's like we're all scientists. We're all
Right.
pursuing the truth and better understanding of our world.
Right.
And so I'm not going to go easy on like, oh yeah, it looks pretty good.
Right.
There you go. Good job. It's like, no. We're trying to make sure that this is as airtight as it can be.
Right.
Rather than trying to be polite to each other or something.
Yes. Sometimes you can be reviewed by your competitor. And often people get eviscerated by reviewers.
Yeah. Yeah.
So there's definitely a level of rigor.
Yeah. That's cool. Good question, Josh. The next question is a fun one. I mean, they've all been fun, but this one's kind of not sciencey. What podcasts do you like? Asks Takesia D.
I love podcasts.
Yeah, me too.
I was so excited when we got this. I'm a prolific podcast listener, and I was trying to think about this before we answered. There are so many I could say. One that I really love that Jam doesn't approve of as much is My Favorite Murder. And one of the big reasons for that is not the content of the murder, although I am really confused as to why people commit murder. So I try to get as many facts as I can about it. But the women in that show, Karen and Georgia host it, and they have actually been surprisingly very encouraging to me. Whenever I was really struggling in the lab and things weren't going well, they were almost a source of constant presence because there was so many hours of backlog podcasts when I found them. Mm-hmm. And they were very encouraging about pursuing the things that you want to pursue and making the most of the things that you have in front of you right now, and very encouraging about women pursuing science. Just a lot of things that were very empowering for me that you would not expect from a murder podcast. So that's been one thing that has been one podcast that's been really beneficial to me.
And I don't approve of it, but not in the sense that like, it doesn't matter what I think about Melissa's podcast tastes. It's more like, I don't like that's not in a category of things that I want to listen to. It doesn't matter that I don't like it.
He doesn't like murder.
Yeah, I don't like murder. So it's like, doesn't stand a chance.
There are others really well-known ones that I love, like Radio Lab. Kind of an interesting new one that I'm starting to enjoy is called Everything is Alive.
Oh, yeah.
Where they just interview inanimate objects. But there are a lot of podcasts that I listen to every single week when they come out religiously, podcasts that I absolutely love. So if you want me to suggest some podcasts for you, just write in and I will hit you up.
We have some overlap of podcast likes. Mm-hmm. Like there's several sciencey ones I think they both really like. I really love Radio Lab as well. And that's one of that probably is the podcast that got me into podcasts, I think.
That's true for me too. Yeah. I was assigned it in a class. That one class, more than any other class in my entire life, has changed my life and has taught me more.
Yeah.
Because of all the things I learned from all these nonfiction podcasts I listened to.
I can't for the life of me remember who told me to listen to Radio Lab or anything like that, but it definitely is what got me into podcasts.
Yeah.
I also like Radio Lab's More Perfect podcast about the Supreme Court. I like This American Life. One of my recent favorites, meaning like the past couple of years that got up there in the tiers of podcasting for me, is Revisionist History by Malcolm Gladwell. And
have you been listening to Finding Fred?
No, I have not.
That one is really good too. Finding Fred is highly recommend, and 99% Invisible.
If you work in like an office place, work culture kind of place, the podcast Work Life with Adam Grant is a must. Like it observes, he's an organizational psychologist, and it is like, it's an amazing podcast. If you don't have a place to apply that stuff, it's still interesting, but it's even more cool if you like work in an office setting. And there's a Bob Dylan podcast I love called Bob Dylan Album by Album. And those are my highlights. There's so many I'm scrolling through here, looking at that I've listened to.
I know I'm subscribed to maybe 30 podcasts right now. So it's hard to separate out which ones I love more. It's so hard.
Yeah.
The Dolly Parton's America made me cry last night, and that's also produced by Radiolab. So
yeah.
That's a really good one.
I'll mention one more if we have time, but it's called Broken Record. It's a music podcast by that's well-known people, but I don't think it's a super well-known podcast. It has Rick Rubin, a really well-known producer. A lot of people have heard his name, but don't know really who he is very well. And a few other people, and they interview musicians and kind of get this like behind-the-scenes music approach. And each episode is really different. They don't have like we're going to make all of them like this. They kind of let the musician and what that person's done or accomplished or currently is doing inform what the episode's going to be like.
Oh, that's really good.
So it's super different. And Broken Record, cool name too. So, and look at their logo. I mean,
very cool.
Yeah.
If you want, we can just screenshot all the podcasts we're subscribed to and post them.
Yeah, that's a good idea. Okay. Man, that's what a question. Loaded question, because we could talk about it the whole time. This next one's from Emily P. Is a bobby pin official scientist equipment? Because now I feel so sciencey and smart and prepared.
Emily P., the answer to that question is yes, 100%. Just like Nancy Drew and Girl Scouts, you always have to be prepared and you have to be ready to use any equipment on hand to accomplish your goals. That's a joke, but I really have found a lot of being a scientist and working in the lab is being very creative with the resources you have, because often there's not enough funds to just buy the equipment you need.
Was that from that video? We use a bobby pin to show the water tension. Okay.
Yeah.
So I was like, where was that from? Yeah, that's right.
So the answer is jokingly yes, but realistically yes also. We've had to use Yeti cups. Once they've been cleaned by the lab, you don't drink out of them again. We've had to use Yeti cups to contain liquid nitrogen. I mean, all kinds of things. When we were low on funds and needed equipment, we would just have to be resourceful.
Yeah.
So in a way, yes. Okay, well, this one I'm going to ask Jam about.
Uh-oh.
Because it's a Jam specific. This was emailed to our joint email account, chemforyourlife@gmail.com. Shoot us an email. It is from Tori M. And she said, "Hey, pal, remember your first football game at UNT? #sports." And attached a photo of Jam at his first UNT football game ever. And I died of happiness.
Yeah. I'm amazed she found that too. So she sent that right after one of my, like, on my high horse about sports being dumb or whatever. And it was the perfect timing to send that, because it was like, I just said something, I think, to your hockey thing. I don't know.
It humbled you a little bit.
I can't remember what we were talking about. So she sent that, and it's pretty funny. That photo is funny too, because like it doesn't really prove that I'm like a sports fan, because I don't look at all happy.
No.
So that was my first UNT football game. I was a freshman, and they had this like weird panorama camera thing, so you could go find yourself in this large photo that actually took a photo of the entire stadium.
Yeah.
And somebody went and found where me and some people were sitting and then tagged us all in it. So I didn't even go do that. But I don't look very happy. I stayed for only half of it. And then I went to another half of the game my sophomore year. So that's the first one was my freshman year. Went to another half of the game my sophomore year. So in my whole career at UNT, I went to one whole football game, but I gave myself a nice year-long break between the two halves. So
Jim, can you explain why you hate sports? I'm sure the listeners are dying to know.
I don't like love competition. I don't love how consumeristic sports are. It's like turned into an entertainment thing, makes so much money. I don't think it's like completely worthless, but I think things like my degree is basically an art degree. To me, that's a lot more important to me. I'm not saying that's important to the world, but to me, art is a lot more important. And so thinking about going to a college football game, and those stadiums are nice and stuff, a lot of money spent on it, and then a lot of money's made on sports as well. I'm just kind of like, man, I just don't like that the world is that way. So
yeah,
that's a really, really, really summarized version. I mean, there's also a lot of stuff about like concerns about kids in high school and middle school and even younger,
right,
playing sports and getting a lot of injuries, a lot of really serious neurological stuff from football that's actually very, very real and a huge problem. Stuff like that.
I totally understand a lot of that. I love sports. Well, really just one sport.
Yeah.
But I also like playing some sports. Mostly because of the nostalgia, and it's something my family's always come around. Me and my dad have always come together around that. And so it really is more about the memories, but there are times I'm bothered by how much sheer money is put into it, how much money people spend on it, that makes me kind of recoil. Some people I know have spent thousands of dollars on just collector's items, which is really mind-blowing to me. So I understand where you're coming from.
Yeah.
I try to take the good and leave the bad.
Yeah.
And I advocate highly for traumatic brain injury research.
Yeah.
A lot of my friends who are speech pathologists have talked to me about that.
Yeah. One last thing I'm just realizing I should have already said is that a lot of male heavy sports just reinforce male stereotypes in a pretty unhealthy way. I'm like, man, that's not me. And that's not a lot of men too. But it's like, it's a kind of unhealthy either standard for men to try to like have to achieve, or just unhealthy characteristics for of competition and unhealthy, I don't know.
Yeah.
So that's another beef I have with it. This is a good time to springboard off into my next podcast venture, No Sports for Your Life, where we'll talk about how every week.
Okay.
So that's all the questions we have. So before we close this episode out, we wanted to thank people who have helped keep our show going. We talked about this a little bit more recently, but it costs us money to make this show. We don't make any money off of it. And so we've had some people give to our Ko-Fi since we recorded our last bonus. We've had some people donate. And so we want to thank you guys. So Esty, Zach, Abby, and an anonymous donor. Thank you guys so much for going above and beyond. We already are so thankful for your listenership, for getting to engage with us and just, you know, allowing us to do what we do just by listening. But also thank you so much for donating to our Ko-Fi. We now have several months of our hosting fees covered.
Woohoo!
Yeah, which is awesome. So that's one of our biggest costs, honestly, at the moment. And so thank you guys so much for donating. That means so much to us.
And thank you guys for listening today to this bonus episode. This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. And we'd like to give a special thanks to E. Robinson, who reviewed this episode.